right, so we got some more algebraic complex fractions. We're going to go ahead and use the LCM method again. Right? If you wanted to use the other method, you'd have to multiply top and bottom by x plus 2, top and bottom by 3x, top and bottom by x, and top and bottom by x plus 2. So the method works. I kind of like it, but we'll use the LCM. So out of all four denominators, we have an x plus 2. Let's see here. We have a 3. And we also have an x. So 3x. Okay, that looks like it covers everything. Yeah, x plus 2 goes into that, and 3x and x go into that. All right. So we'll multiply top and bottom by this. X plus 2, 3x. We'll see what we get here. All right. So that times 1 over 3x. The 3x's cancel, and we're just left with x plus 2 minus, for this one, we'll have a 4, and then the x plus 2's cancel, so we're left with a 3x over, let's see here, we'll have an x, the x plus 2's cancel, and we have a 3x plus, let's see here, we have a 1, so that doesn't do anything. That x cancels with that x, and we're just left with 3 and then an x plus 2. Okay, let's go ahead and simplify. We've got x plus 2 minus 12x over 3x squared plus 3x plus 6. Okay, this will be negative 11x plus 2. And then on the bottom, we still have the same thing. We can factor out a 3 if we wanted to, but the 3 is not going to cancel with anything up here. All right, so 3x squared plus 3x plus 6. Now I guess you could try to factor this, after you factor out the 3, and then see if there's a factor that would cancel with this negative 11x plus 2, but there's no way. I mean, if you factor out the 3, you're going to be dealing with a leading coefficient of a 1, so it's not going to work out. All right, so that one's good. All right, this one next. Just go with the LCM method. Actually, the only multiple here is a 2x plus 3. So we'll be multiplying top and bottom by 2x plus 3. Okay, so we'll have 2x plus 3 times all of this. So that's going to give us 2x squared. Let's see. Plus 3x minus 8x minus 12. Okay, and then we'll have 2x plus 3 times this, and that's just going to be a 9. Okay, now we'll have 2x plus 3 times this, so we'll have 2x squared plus 3x plus 6x plus 9. And then we'll have 2x plus 3 times that, and that'll just be a minus 5. All right, let's combine common terms. 2x squared, we'll have negative 5x. This will be negative 3. 2x squared, this will be a 9x. And then this will be a 4. And yeah, we actually have to try to factor this. There's a chance we might have a factor that cancels here. So I don't think I have to use the x method here. We're just dealing with, a 2 out front, so it should be pretty easy. I'm actually going to do the bottom one first. You'll notice on the bottom one we've got same signs. All right, so the order here is not going to matter. All right, factors of 4. Let's see. We could do 2 and 2. which would not give us a 9. Or we could do 4 here and a 1 there. All right. So this will be an 8x, this will be a 1x, and that's going to give us our 9x. Okay. So for factoring this one, really the only thing we're looking for is if there's going to be a 2x plus 1 or an x plus 4. That's all we really care about. Yeah, I guess I'll try the options here. So factors of negative 3 that add up to negative 5. Oh, sorry, factors of negative 6, and because we have a 2 here, that give us negative 5. That's going to be negative 6 and positive 1, but then we have to divide them by 2. Oh, what am I? Is that right? Factors of negative 6 that add up to negative 5. That's right. And then I would divide these by 2. Yeah, okay, sorry. Yeah, I divide these by 2. This one is going to be a negative 3. So we would have an x minus 3 as one of the factors, and this one's going to be 2x plus 1. Oh, okay, so we do have a factor that cancels. Good. Glad we checked. All right, that cancels with that, and we're left with x minus 3 over x plus 4. Good.